Hey y'all, it's Miss Johnson. Sorry I wasn't in class today. That's the way it goes sometimes. This afternoon we're going to extend the work from Tuesday, which was finding the area between two curves, right? On Tuesday we talked about things that looked like this, where there was a red curve and a blue curve, and we found the purple stuff in the middle. And we did this by finding the intersection of these two curves, figuring out which one was the top, which one was the bottom, and then setting up an integral, a definite integral, which represents area. Right, today we're going to answer the question that one of y'all had in class, I think it was Ethan had in class, which was what happens if at some point the red is on top, but on other points the purple is on top, right? And the answer, I know y'all are going to love this, two integrals, right? If we have functions that meet each other in several places and create several pockets where we could have area, right? And where over here red is on top and over here blue is on top, over here the bottoms are different, right? The process is the same, right? We still find the intersections. So something like this would be -1, maybe 10, maybe 14, right? We would still graph and label the top and the bottom. And then in the setup, instead of going from -1 all the way to 14, we would go to 10 first, have the red function minus the blue function, right? And then add that area to this area, which is going from 10 to 14, where the blue function is on top, and we subtract the red function being on the bottom, right? This ensures that these areas don't cancel each other out. This ensures that we're actually getting what we came here to get, which is the area of the space that these two curves make between each other. Then, when we take the antiderivative, when we do the step 4 calculus stuff, the antiderivative here and the antiderivative here are going to look really similar. They're actually just going to be negatives of each other. So we're not doing like a bunch of calculus. We're not doing it like several times. We're doing it once and then kind of, plugging in a bunch of different stuff. Let's see what that looks like with a real example instead of this kind of fake example. Better. All right. These two examples I'm going to do on the video look pretty similar to the ones on your homework. So, pay attention, take notes, do your homework alongside it. We should be good. All right. Find the area between y equals -x plus 4 and y equals 2x cubed minus 3x squared minus 4x plus 6. All right. The first step is finding the intersections, and the second step is graphing these functions. I'm going to do both of these steps at the same time. I'm going to go over to Desmos, right? Did I do this right? Which one's red? Oh, I'm amazing. I'm the best there ever was. Okay, so I graphed my longer polynomial in red. I graphed my linear line in blue on desmos.com/calculator. And then, so now I know which one's on the top and which one's on the bottom at certain points. And in Desmos, what you can do is you can hover over these lines and you can click the intersection points and they'll just pop up for you. What an amazing website. I'm going to go ahead and screenshot this and put it into my notes. I highly recommend you do this for your own work. That's pretty big. Resize that. Now it looks worse, but that's how it goes. And then the main thing I want to do is point out that this is one of the spaces we're trying to find the area of, and this is the other. Here, the red is the top, and here, the blue is the top, right? The intersection points are at x equals, what, -1 here, at 0.5 here, and at 2 here. Great. We've now found the intersections and we've graphed and labeled top to bottom. The intervals are what we're about to do. 3, the setup, will have the same number of integrals as there are little spaces. right? So we're going to have two integrals here because there's two areas we're trying to find. I'll probably do those on two different lines. For the first integral, we go from the first intersection to where it switches over. We put the top function first. The bottom function second, subtracting those two. Bottom function here is this. And now we have at it. Now we just do the actual calculus, right? Roll our sleeves up and get it done. Important is to remember to put parentheses here, right? The next thing we do is we add the second area, right? So now we've got this one set up. Now we need to set up this area. It goes from 0.5 to 2. And it's basically the opposite of what's going on here, right? The top function is now our linear line, and the bottom function is now our nonlinear polynomial. It's all this stuff. Great. And now we get going, right? We've set up all of our integrals, purple. And now we just actually need to do the calculus, right? The first thing we're going to do is simplify like algebraically, right? I don't want all of this. I'd rather just have the same thing. So we've got 2x cubed minus 3x squared. This is negative 4x minus a negative x. So negative 4x plus x, which makes it negative 3x. And then this is 6 minus 4, which is 2, as expected, right? The next integral still goes from 0.5 to 2, and it's basically just going to be the reverse of this, right? It's going to be a negative 2x cubed. It's going to be a positive 3x squared. It's going to be a positive 3x, and it's going to be a negative 2. You can check my math on that if you want to, but I'm right. And this is a faster trick, right? We know that when we do 3 minus 2, it's the inverse of 2 minus 3, right? This one's 1 and this one's negative 1. The same thinking applies here, right? If we do something minus something else, then it's going to be the negative of the something else minus the initial something. Great. Now let's actually do the antiderivatives, right? The first one says 2/4 x to the fourth minus 3/3 x to the third minus 3/2 x squared plus 2x. These are all power rule stuff, right? We use the power rule here. Power rule. If you need notes, the notes from class on 420 have all these notes. No, from the video on 420 have all these notes. And then this is from -1 to 0.5. We're going to add this. So this was all of this turned into this. And we're going to add this to the same thing for the different bounds. Turns out I'm not going to think about this twice. I'm going to rewrite everything I just wrote, but where there's pluses, I'm going to put minuses, and when there's minuses, I'm going to put pluses. With my new boundaries to 2. Great. This is where I actually just go nuts and plug this in. I'm going to put this here so you know exactly what's going on. The orange one becomes, and I'm going to simplify these as we go, 2/4 is 1/2, 3/3 is 1, 3/2 is already simplified. Go team. Oof. Nope. Got there. Paste. I know y'all love me being technologically illiterate while I'm doing this on video. You can just speed up through this part, I guess. Oh, so close. That's going to be close enough. Okay. For the orange stuff, which is what I'm doing here, right? I am plugging in a 0.5 here, a 0.5 here, a 0.5 here, and a 0.5 here. And I'm plugging in a -1 here, 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 and here. Then I'm going to add it to all the green stuff, which is hilariously all the same thing, right? -1/2 something to the 4th, plus something to the 3rd, plus 3/2 something squared, plus, sorry, minus 2 times something. Subtract, paste, all of that with a different thing. Here I'm plugging in 2, and here I'm plugging in 0.5. That is, in fact, what I want to do. Nice. 0.5. Here's the point in the video where I should have done this beforehand. So let me do this on the night real quick. We want to do from alpha.com, area between curves. Integral. Definitely fast forward this part. Oh my god. I can't type. X equals 0.5 of, what's even my thing? 2x cubed. So that one's 2.53. And then the green one will be 5 to 2. That's the negative version of all of this. I think I did the parentheses wrong. Yes. And that one is also 2.53. Hilarious. Well, that's how it is sometimes. So that is 5.06. Bingo bongo. You can come back now. Okay, so again, what we did, let me just run through this one more time. We graphed our two curves in Desmos. We clicked on the intersection points so we could write down the intersections, and then we set up our integrals, right? Our first space, which I was outlining in orange, is set up as the red line minus the blue line. And the integral that I set up in green is the blue line minus the red line on the intervals that are important to us, right? And then once we do here, we kind of stop thinking about this as a word problem and we start thinking about it as just straight calculus. We simplified algebraically without taking any integrals, right? Then once we were as simplified as possible, we did the power rule on both of these to actually find the antiderivative, to actually do the integral. Then we plugged in the top and the bottom bounds to both of these. We plugged this mess into a calculator and got 5.06. Let's run it back. Let's do it again. This time we're going to find the area between y equals 0.3x and y equals sine x. We're going to do steps 1 and 2 at the same time on desmos.com/calculator. I have graphed 0.3x as the red function and sine x as the blue function. So here we are. I am going to click on my intersections so I know exactly the points I'm looking at. Bada bing. Go away. Okay. And then we're going to set up these intervals, right? There's two spaces we're interested in, the orange and the green again. We could do these as two separate calculations and then add them at the end. I've been doing them in the same line just because I'm greedy, I guess. So what we're going to do is we're going to do the integral. I'll do it all in orange, actually. The integral from negative 2. Let's call it 4 to 0 of the top function, which here is 0.3x, minus the bottom function, which here is sine x. We're going to add that to the area of the green space, which is from 0 to 2.4. Here, sine being on top and the line being on bottom. I chose not to put parentheses here. I could have, probably should, right? But that's because there's nothing really to distribute because each of the functions is only one term, right? Just putting the minus sign is good enough. Let's do some integration. Our functions are simplified, right? So now the thing to do is use our notes to find the antiderivatives. The antiderivative of this is 0.3 divided by 2 to the power of 2. That's the power rule. And then the derivative of negative sine is positive cosine. We go from here to here. Now we add on the derivative of positive sine is negative cosine. The antiderivative. And the antiderivative of negative 0.3x is negative 0.3 divided by 2x squared. Again, writing our bounds. Great. We have our antiderivative. Now we have to plug in our boundaries. 0.3 divided by 2 is 0.15. Something squared plus cosine of whatever. Minus the same thing, but plugging in a different number. Copy paste. Thing. This one we're plugging in 0 up top and negative 2.4 to the left, to the right, whatever. And then we're going to add the same thing but in green, right? This is the negative cosine of something minus 1.15 something squared minus the same thing but plugging in the other number, copy paste, brushes. Here we're going to plug in 2.4 first because it's the top bound, and then we'll plug in 0 next because it's the bottom bound. This is something we put into our calculator, right? I'm going to do that now. Kind of memorize this. 0.5x squared cosine. Cosine of 0 minus. And then, so that was 0 up top and negative 2.4. The bottom, negative 2.4 at the bottom. And we want to add this to the same thing, but all of them are negative. So over here, this is now the negative version. This is now the negative version. This becomes a plus. This becomes a plus. I could have done this better. This is a 0. This is a 0. This is a 2.4. This is a 2.4. Okay. Thank God. Okay. So that is that, good, perfect. So it's negative. Ooh, should not be negative. Because this is a plus. And this is a minus. Okay, yeah, nice. And now we have a positive area, which is great, which is 1.746. Scroll down. 1.746. Nice. All right, that's the process, y'all. It's the same thing, but each of these are basically two of these little area questions because there's two little areas. Calculus is a big test of organizational skills, right? If you're feeling overwhelmed about the math, that makes a lot of sense. If you're feeling overwhelmed by the organization, that also makes a lot of sense. Know that these are two different skills. I am asking both of them of you. So if you need any help, reach out to your classmates, reach out to your substitute teacher, message me on Teams, and I'll get back to you when I'm back at it. But other than that, happy weekend. I'll see y'all on Tuesday, and I will see the Cohort B people in person next Friday. Cheers.